Hi everyone, my name is Jesus Polito, also known by Jay Polito, and today I have video 4, which is going to be on impulse and momentum analysis. We have our shopping cart collision. Yeah, the scenario is simple. A loaded cart A, is pushed into a stationary cart B. They bounce off each other. Our goal is to determine their velocities immediately after this impact. We'll model this as a direct central impact problem. We have our given and assumes. We have a loaded cart A with a mass of 45 kilograms moving at a speed of 1.5 meters per second. Again, that car is already loaded with groceries. We have the empty cart B with a mass of 15 kilograms, which is initially at rest. And then we're going to model the bounce using a coefficient of restitution for this plastic and metal impact. We'll assume the value of E equals to 0.6. Our key assumptions are that the two cars form our system. External forces like friction are non-impulsive during the brief moment of impact, and the motion is one-dimensional. Here we have our free body diagrams and sketches before the collision, during the collision, and then after the collision. So first, the free body diagram shows that the net external impulse on the system is 0, which means that the principle of conservation of momentum applies. The impulse momentum diagrams for each individual cart shows the internal impulsive force acting during the collision. And then finally, our kinematic sketch defines these states before and after impact. With the setup complete, we apply our two equations. First, the conservation of linear momentum for the system. The total momentum before the collision must equal the total momentum after. And then second, we use the coefficient of restitution equation, which for our value of E is equal to 0.6, relates the relative velocities of the separation and the approach. And then this gives us a system of two equations with two unknowns. And then solving them at the same time is pretty straightforward. We substitute and then find out that the final velocity of the cart A is 0.9 meters per second, and the final velocity of cart B is 1.8 meters per second. Both continue moving to the right, with the lighter cart moving faster. And by applying conservation of momentum and coefficient of restitution, we can successfully model this real-world collision. Thank you.